Now, in this lecture, we'll find out the value of angle theta. In the drawing, we have triangle ABC, side CA equals to side CB, therefore triangle ABC is an isosceles triangle. In addition, we know that this angle ACB equals to 20 degrees in its size. This angle NAB equals to 50 degrees in its size. And this angle ABM equals to 60 degrees in its size. Again, our mission is to find out the value of angle NMB, that is actually angle theta. So we'll focus on triangle ABC. So I'll copy triangle ABC in a new page, and we'll analyze this triangle ABC. So actually, this is triangle ABC that I call it from the original drawing. Side CA equals to side CB. And we have the rule that in front of equal sides in the triangle, there are equal angles. Okay, so those two angles that are located in front of the equal sides must be equal to each other. So if this angle equals to theta, then this angle must be also equal to theta. And we also know that the sum of the angles in triangle ABC must be equal to 180 degrees. So which angles we have inside triangle ABC? We have this angle that is theta plus this angle that is also theta. Theta plus theta is 2 theta plus 20 degrees. In total, the sum of those three angles must be equal to 180 degrees, according to the rule that the sum of the angles in any triangle is equal to 180 degrees. 2 theta plus 20 degrees equals to 180 degrees. We subtract 20 degrees from this equation, and we get that 2 theta equals to 180 degrees minus 20 degrees. It is 160 degrees. We divide this equation by 2, and finally we get that angle theta equals to 160 degrees over 2, which is 80 degrees. So angle theta equals to 80 degrees, and this is angle theta that is also equals to 80 degrees in its size. And here also, this is angle theta that is equal to 80 degrees. But because of the fact that this angle NAB equals to 50 degrees, therefore the rest here, this angle must be equal to 30 degrees. In order to complete the size of this angle theta to 80 degrees, this angle must be equal to 30 degrees. Likewise, this is also angle theta that is equal to 80 degrees. But this angle MBA is only equal to 60 degrees. So the missing angle must be equal to 20 degrees in order to complete the size of this angle theta to 80 degrees. The missing angle here must be equal to 20 degrees. Okay, so in the next step, we'll focus on triangle NAB, this triangle. So I'll copy triangle NAB in a new page and we'll analyze it. This is angle theta is equal to 80 degrees in its size. This angle NAB equals to 50 degrees in its size. So actually, this is triangle NPA, is according to the original drawing. We define the missing angle as theta in triangle NBA. The sum of the angles must be equal to 80 degrees. So which angles we have in triangle NBA? We have 50 degrees plus 80 degrees plus theta. In total, the sum of those three angles must be equal to 180 degrees. 50 plus 80 is 130, so we'll subtract 130 degrees from this equation. And we get that angle theta equals to 180 degrees minus 130 degrees, it is 50 degrees. So actually angle A and B, that is theta, it is equal to 50 degrees in its size. We write down in the original drawing that this angle A and B equals to 50 degrees in its size. We continue to focus on triangle NBA. This triangle NBA, we have two angles that are equal to each other. Again, we have the rule that in front of equal angles in the triangle are equal sides. So those two sides that are located in front of those two equal angles must be equal to each other. That is to say, side AB equals to side NB. AB equals to NB. I write it down here. That side AB equals to side NB. Side AB equals to side NB. Okay. In the next step, we'll focus on triangle AMB. So I'll copy this triangle AMB in a new page and we'll analyze it. This is angle theta that is equal to 80 degrees in its size. This angle ABM equals to 60 degrees in its size. So actually, this is triangle A and B that I copied from the original drawing. We we find the missing angle as theta. In triangle A and B, the sum of the angles must be equal to 180 degrees, therefore 80 degrees plus 60 degrees plus this angle theta, in total they must be equal to 180 degrees. 80 plus 60 is 140, so we subtract 140 degrees from this equation, and finally we will get that angle theta equals to 180 degrees minus 140 degrees, it is 40 degrees. So actually angle A and B, that is actually angle theta, equals to 40 degrees in its size. We write it down here. That this angle A and B equals to 40 degrees in its size. Okay. So in the next step, from point B, we draw line segment BD on CA. Again, from point B, we draw line segment BD on CA in such a way that BD will be equal to BA. Okay? So here, we constructed this line segment BD in such a way that BD equals to BA. I write it down here. That BD equals to BA according to our construction. BD equals to BA according to our construction. Here BD equals to BA. In the next step, we'll focus on triangle ADB. So I copy triangle ADB. This triangle ADB is in operation. We will analyze it. This is triangle ADB that I copied from the original drawing. AD equals to AB according to our construction. Again, we have the same rule that in front of equal sides in the triangle are equal angles. So those two angles that are located in front of equal sides must be equal to each other. But this is angle theta that is equal to 80 degrees. Therefore, this angle that is equal to this angle, those two angles are equal to each other, must be also equal to 80 degrees in its size. So I write it down here that angle ADB must be equal to 80 degrees in its size. This is angle ADB must be equal to 80 degrees in its size. We continue to focus on triangle ADB, that is actually an isosceles triangle. The sum of the angles in triangle ADB must be equal to 180 degrees, that is to say 80 degrees plus 80 degrees plus we define the missing angle as theta plus theta. In total, the sum of those three angles must be equal to 180 degrees. 80 plus 80 is 160 plus theta equals to 180 degrees. We subtract 160 degrees from this equation, and finally we get that angle theta equals to 180 minus 160 is 20 degrees. So this angle theta equals to 20 degrees in its size. Angle ABD equals to 20 degrees in its size. This is angle ABD that is equal to 20 degrees in its size. So here the big angle MBA, this angle equals to 60 degrees. The small angle DBA equals to 20 degrees in its size. Therefore, the missing angle MBD must be equal to the big angle minus the small angle. I write it down. The big angle is angle MBD, that is equal to 60 degrees in its size. This is actually angle MBA. This is the big angle MBA, that is equal to 60 degrees in its size, minus the small angle that is actually angle DBA, that is equal to 20 degrees in its size, will be equal to the missing angle that is actually MBD. Angle MBD. Repeat again. The big angle, this angle MBA is equal to 60 degrees, whilst the small angle, that's actually angle DBA, that is equal to 20 degrees in size, will be equal to the missing angle, that's angle MBD. So the big angle is equal to 60 degrees in size, the small angle DBA equals to 20 degrees in size, therefore 60 minus 20 is 40 degrees. So the missing angle MBD equals to 40 degrees in its size. So I write it down here. That the missing angle, angle MBD equals to 40 degrees in its size. In the next step, we'll focus on triangle DMB. So I will copy triangle DMB in a new page and we will analyze it. Angle DMB equals to 40 degrees in its size. This is angle DMB that is equal also to 40 degrees in its size. Okay, this is triangle DMB that I copied from the original drawing. Again, we have here those two angles that are equal to each other. And we have the rule that in front of equal angles in the triangle, there are equal sides. So those two sides that are located in front, the equal angles must be equal to each other. That is to say, side DM must be equal to side DB. DM equal to side DB. So I write it down here. Then DM equals to DB. AM equals to BB. Okay. In the next step, we join points D and N together by a straight line. And we'll focus on the right triangle DNB. So I'll copy the great triangle DNB in a new page and we'll analyze it. Angle DBN, this angle equals to 40 degrees plus 20 degrees, that is 60 degrees. And we already found out that side DB, yeah, side DB equals to side NP. Okay, we can also conclude it from those equations. From one side, side AB, it is equal to side NB. AB equals to NB. From the other side, AB equals to BD. Here, AB equals to BD. And from this equation, BD equals to AB equals to NB, we will derive that side BD equals to side NB. Here, side BD equals to side NB. Side BD equals to side NB. So this is triangle DNB theta covered from the original drawing. DB equals to NB. Again, we have the rule that in front of equal sides in the triangle, there are equal angles. So those two sides are equal to each other. Those two sides are located in front of those two angles. Therefore, those two angles must be also equal to each other. So if one angle, this angle equals to theta, then the other angle must be also equal to theta. And we have the rule that the sum of the angles in any triangle is equal to 180 degrees, and especially it is true in triangle DNB. So which angles we have here in triangle DNB? We have this angle that is equal to 60 degrees, plus this angle that is theta, plus this angle that is also theta. In total, the sum of those three angles equals to 180 degrees. Theta plus theta is 2 theta, so 60 degrees plus 2 theta equals to 180 degrees. we subtract 60 degrees from this equation, we will get that 2 theta equals to 180 degrees minus 60 degrees. It is 120 degrees. 2 theta equals to 120 degrees. We divide this equation by 2. And finally we get that angle theta equals to 180 degrees over 2. That's 60 degrees. So I found out that angle theta equals to 60 degrees in its size. This is angle theta that is equal to 60 degrees. This is also angle theta that is equal to 60 degrees. 60 degrees. So actually we found out that in side triangle DNB we have triangles that are all equal to 60 degrees. Therefore triangle DNB is an isosceles triangle. So I write it down. Triangle DNB is an equilateral triangle. All of its angles equals to 60 degrees. Therefore, triangle DNB is an equilateral triangle. So the great triangle DNB is an equilateral triangle all the angles, all the sides in any equilateral triangle are equal to each other. That is to say, in triangle DNB, side DN equals to side DB, and it is equal to side NB. I'll write it down here. The DN equals to DB equals to NB. Okay. So here we have side DN equals to side DB equals to side NB. DB equals to DM. One side DB equals to DM. Here DB equals to DM. But from the other side, DB equals to DN. DB equals to DN. DB equals to DN. And from this equation, DB equals to DM, DB equals to DM equals to DB equals to DN, we will derive that DM equals to DN. DM equals to DN. Okay, DM equals to DN. Here, this is side DM that is equal to side DN. In the next step, we'll focus on the straight line CA, on this side of the straight line CA at point D. So which angles we have at this side of the straight line CA at point D? We have this angle that is equal to 80 degrees. This angle is one out of three angles of the equilateral triangle BND, therefore it is equal to 60 degrees. Okay. So here at this side of the straight line CA at point D, we have this angle is equal to 80 degrees, this angle equals to 60 degrees. 80 plus 60 is 140, and therefore the missing angle here must be equal to 40 degrees. According to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. So 140 plus 40 it is 180 degrees exactly according to the rule that I mentioned. So actually angle CD, angle, this is the missing angle, is equal to 40 degrees in its size. So actually angle MDN. Angle MDN equals to 40 degrees in its size. In the next step, I will copy triangle MDN in a new page and we'll analyze it. We have already found out that dm equals to dn. Here, side dm equals to dn. Here, dm equals to dn. So this is triangle MDN that I copied from the original drawing. Angle MDN equals to 40 degrees and dm equals to dn. Again, we have the rule that in front of equal sides in the triangle, there are equal angles. So in front of those two sides that are equal to each other, we have those two angles that must be also equal to each other. So if this angle is theta, this angle must be also equal to theta. The sum of the angles in triangle MDN must be equal to 180 degrees. So that is to say 40 degrees plus theta is 2 theta, must be equal to 180 degrees. Here we will subtract 40 degrees from this equation and we will get that 2 theta equals to 180 degrees minus 40 degrees, it is 140 degrees. So 2 theta equals to 140 degrees, we will divide this equation by 2. And finally we get that angle theta equals to 140 degrees over 2, it is 70 degrees. So angle theta equals to 70 degrees in its size. Here, angle DMN equals to theta that is equal to 70 degrees. So angle DMN, it is the big angle that is equal to 70 degrees. Again, angle DMN equals to 70 degrees in its size, the big angle. So the big angle DMN that is equal to 70 degrees in its size minus the small angle that is actually angle DMB. Angle DMB equals to 40 degrees in its size. So the big angle DMN minus the small angle DMB must be equal to angle theta. That is the angle that we are looking for. Angle theta is actually angle DM. Angle theta is actually angle NMB. Repeat again. the big angle DMN minus the small angle DMB must be equal to the missing angle, angle theta, that is the angle that we are looking for. Again, the big angle DMN is equal to 70 degrees, minus the small angle DMB is equal to 40 degrees, must be equal to angle theta, that is actually angle NMB. That is the angle that we are looking for. So the big angle equals to 70 degrees, the small angle equals to 40 degrees, 70 degrees minus 40 degrees, it is 30 degrees. So actually found out that the missing angle, angle theta, that is angle NMB, that is the angle that we are looking for, equals to 30 degrees in its size. Okay, that is the answer to the question. In the next step, I will summarize the lecture. So in this lecture, found out the size of angle NMB, that is actually angle theta. In the drawing we have triangle ABC, that is an isosceles triangle, because CA, side CA equals to side CB. In addition, this angle ACB equals to 20 degrees in size. This angle NAB equals to 50 degrees in size. And finally, this angle MBA equals to 60 degrees in size. Our mission is to find out the size of this angle NMB, that is equal to theta. So first of all, I copied triangle ABC in a new page and I analyze it. So this is triangle ABC that I copied from the original drawing. Angle ACB equals to 20 degrees in size, and we know that CA equals to CB. CA equals to CB. That is to say, triangle ABC is an isosceles triangle, and we have the rule that in front of equal sides in the triangle there are equal angles. So in front of those two equal sides, we have those two angles that also must be equal to each other according to the rule that I mentioned. So if one angle is theta, then the other angle must be also equal to theta. And we have the rule that the sum of the angles in any triangle is equal to 180 degrees, and especially it is true in triangle ABC. So which angles we have in triangle ABC? We have this angle is equal to 20 degrees plus theta equals to 180 degrees. So 20 degrees plus 2 theta equals to 180 degrees. We subtract the 20 degrees from this equation, and finally found out that 2 theta equals to 180 degrees minus 20 degrees, it is 160 degrees. So 2 theta equals to 160 degrees. We divided this equation by 2, and finally we found out that angle theta equals to 160 degrees over 2, it is 80 degrees. So those two angles that are defined as theta equal each other equals to 80 degrees in size. So this is angle theta that is equal in total to 80 degrees in size. So this is actually angle theta that is equal to 80 degrees in size. But because of the fact that this angle is already equals to 50 degrees, therefore the missing angle must be equal to 30 degrees. In order to complete the size of angle theta to 80 degrees, the missing angle here must be equal to 50 degrees. Likewise, this is angle theta that is equal to 80 degrees. But because of the fact that this angle MBA, it is already equal to 60 degrees, and it is part of angle theta, therefore the missing angle must be equal to 20 degrees. Okay? In order to complete the size of angle theta to 80 degrees, the missing angle must be equal to 20 degrees. In the next step, we focus on triangle A and B, so I copy triangle A and B in a new page and we analyze it. So actually, this is triangle A and B that I copied from the original drawing. Angle NAB equals to 50 degrees in size. This is angle BA is equal to 80 degrees in its size. It is angle theta. And this is the missing angle. We define the missing angle as theta. The sum of the angles in triangle NAB must be equal to 180 degrees, that is to say 50 degrees plus 80 degrees plus angle theta. In total, the sum of those three angles must be equal to 180 degrees, according to the rule that the sum of the angles in the triangle is equal to 180 degrees. 50 degrees plus 80 degrees is 130 degrees. So we subtract 130 degrees from this equation, and finally found out that angle theta equals to 180 degrees minus 130 degrees, it is 50 degrees. 180 minus 130 is 50 degrees. So the missing angle here, angle theta equals to 50 degrees in its size. Angle theta is actually angle NAB, that is equal to 50 degrees in its size. Angle A and B equals to 50 degrees in its size. So we continue to focus on triangle A and B. On triangle NAB, we have two angles that are equal to each other, each of them equal to 50 degrees, therefore they are equal to each other. Again, we have the rule that in front of equal angles in the triangle, they are equal size. That is to say, those two sides that are located in front of the equal angles must be equal to each other. That is to say, side AB equals to side NB. AB equals to NB. Here AB equals to NB, and AB equals to NB. Okay, so in the next step, we focus on triangle A and B. So I call it triangle A and B in a new page and we analyze it. So actually, this is triangle A and B that I call it from the original drawing. Angle MAB is this angle theta that we found in the beginning of the lecture, that is equal to 80 degrees in size. Angle MBA equals to 60 degrees in size. Okay? And the missing angle is theta. The sum of the angles in triangle MAB must be equal to 180 degrees, that is to say 80 degrees plus 60 degrees plus the missing angle theta. In total, they must be equal to 180 degrees. 80 plus 60 is 140, plus theta equals to 180 degrees. We subtracted 140 degrees from this equation and finally found out that angle theta equals to 180 degrees minus 140 degrees, it is 40 degrees. So this is the missing angle theta, that is equal to 40 degrees in its size. Angle A and B equals to 40 degrees in its size. This is angle A and B, that is equal to 40 degrees in its size. In the next step, we did a construction from point B. We draw line segment BD in such a way, so we draw line segment BD on CA in such a way that BD will be equal to BA. Again, BD equals to BA according to our construction. Okay. BD equals to BA according to our construction. And then I copy triangle ADB in a new page and we analyze it. This is triangle ADB that I copy from the original drawing. This is the angle that we found out at the beginning of the lecture, that is equal to 80 degrees. And again, AB equals to DB equals to AB according to our construction. And we have the same rule that in front of equal sides in the triangle there are equal angles. In front of those two equal sides we have those two angles that must be also equal to each other. But because of the fact that this angle equals to 80 degrees, therefore this angle must be also equal to 80 degrees. So if angle ADB equals to 80 degrees in its size, this is angle ADB, this angle equals to 80 degrees in its size. Then we continue to focus on triangle ADB. The sum of the angles in triangle ADB must be equal to 180 degrees. That is to say 80 degrees plus 80 degrees plus the missing angle, that is theta. In total, they must be equal to 180 degrees. 80 plus 80 is 160. So 160 plus theta equals to 180. We subtracted 160 degrees from this equation. And finally, we found out that the missing angle theta equals to 180 degrees minus 160 degrees. It is 20 degrees. This is the missing angle theta that is equal to 20 degrees in size. That is to say, angle ABD equals to 20 degrees in its size. This is angle ABD that is equal to 20 degrees in its size. So the big angle ABM equals to 60 degrees in size. The small angle ABD equals to 20 degrees in its size. And the missing angle is angle DBM. Actually, the big angle ABM minus the small angle ABD must be equal to the missing angle DBM. I repeat again. The big angle MBA that is equal to 60 degrees minus the small angle DBA that is equal to 20 degrees must be equal to the missing angle, that is angle MBD. Okay, here. This is equal to 60 degrees and this is equal to 20 degrees, therefore the missing angle is here. This is the big angle minus the small angle. So the big angle that is 60 degrees minus the small angle that is 20 degrees, 60 minus 20 is 40 degrees, so the missing angle MBD equals to 40 degrees in its size. This is the missing angle MBD that is equal to 40 degrees in its size. In the next step, I copied triangle MBD in a new page and we analyzed it. So okay, this is triangle MBD that I copied from the original drawing. Angle MBD, we just right now found out that angle MBD equals to 40 degrees in size, and we have already found out that this angle DMB equals to 40 degrees in its size. Again, we have the same rule that in front of equal sides in the triangle there are equal angles. In front of equal angles in the triangle there are equal sides. So in front of those two equal angles, we have those two sides that must be also equal to each other. That is to say, side DM equals to side DB. DM equals to DB. So we write down here that DM equals to DB. DM, here this is DM, is equal to DB. Those two sides are equal to each other. Then we focus on triangle DNB. This is triangle DNB. So it is triangle. We actually from point D, we join points D and N together by a straight line. Okay, we join points D and N together by a straight line. In this way, we created the green triangle DNB. In the green triangle DNB, angle NBD equals to 40 degrees plus 20 degrees, that is 60 degrees, and side DB equals to side NB. So actually, this is the green triangle DNB that I copied from the original drawing. Angle NBD equals to 60 degrees and DB equals to NB. So in front of equal sides in the triangle there are equal angles. So in front of those two equal sides we have those two angles that must be also equal to each other. So if one angle is theta, then the other angle must be also equal to theta. In triangle DNB, the sum of the angles must be equal to 180 degrees. That is to say, theta plus 60 degrees must be equal to 180 degrees. So 60 degrees plus 2 theta equals to 180 degrees. We subtracted 60 degrees from this equation and finally found out that 2 theta equals to 180 degrees minus 60 degrees. It is 120 degrees. We subtracted 60 degrees. So 2 theta equals to 120 degrees. We divided this equation by 2 and finally found out that angle theta equals to 120 degrees over 2, it is 60 degrees. We found out that angle theta equals to 60 degrees, so this is angle theta that is equal to 60 degrees, and this is also angle theta that is equal to 60 degrees in its size. So inside triangle DNB we have 3 angles, that all of those 3 angles are equal to 60 degrees in the sizes. Therefore triangle DNB is an equilateral triangle. I repeat again. triangle, the green triangle DNB is an equilateral triangle. And we know that all the sides in any equilateral triangle are equal to each other. That is to say, in the green equilateral triangle, side DN equals to side DB equals to side NB. Again, side DN equals to side DB equals to side NB. Okay? So here, DN equals to DB equals to NB. Here also DN equals to DB equals to NB. And here we know that DB equals to BA. So from one side DB equals to DB equals to DM. For one side DB equals to DM according to this equation. DB equals to DM according to this equation. From the other side DB equals to NB. Here, from here DB equals to NB. DB equals to DB equals to DM. Here DB equals to DM. So from one side DB equals to DM, from the other side DB equals to DN. Okay? And from this equation DB equals to DM equals to DB equals to DN, we will derive that DM equals to DN. Here, DM equals to DN. Okay? DM equals to DN. And then we focused on this side of the straight line CA at point D. Okay? So which angles we have on this side of the straight line CA at point D? We have one angle, this angle equals to 80 degrees in its size. This is one out of three angles of the equilateral triangle DNB, therefore it is equal to 60 degrees, plus the missing angle. So this angle equals to 80 degrees, this angle equals to 60 degrees. 80 plus 60 is 140. 140 plus 40 equals to 180 degrees. The missing angle must be equal to 40 degrees in order to complete the sum of the angles on this side of the straight line CA to 180 degrees. The missing angle must be equal to 40 degrees. Okay, so this is the missing angle MDN that must be equal to 40 degrees in its size. Okay, so then I copy triangle MDN in a new page and we analyze it. This is triangle MDN that I copied from the original drawing. We just right now found out that angle MDN equals to 40 degrees in its size, and we already found out that DM equals to DN. Here DM equals to DN. Okay. Here side DM equals to side DN. Again, we have the same rule that in front of equal sides in the triangle there are equal angles. So in front of those two equal sides, we have those two angles that must be also equal to each other. So if one angle is theta, then the other angle must be also equal to theta. And we have the rule that the sum of the angles in a triangle is equal to 180 degrees. So in triangle DMN, 40 degrees plus theta equals to 180 degrees. That is to say 40 degrees plus 2 theta equals to 180 degrees. We subtracted 40 degrees from this equation and finally found out that 2 theta equals to 180 degrees minus 40 degrees, it's 140 degrees. We divided this equation by 2 and found out that angle theta equals to 140 degrees over 2, it is 70 degrees. So finally we found out that this is angle theta, that is actually angle DMN, that is equal to angle theta equals to 70 degrees. 140 degrees over 2 is 70 degrees, so angle DMN equals to 70 degrees in its size. So actually this is angle DMN, the big angle DMN equals to 70 degrees in its size. The small angle DMB equals to 40 degrees in its size. It is very easy to see from the drawing that the big angle DMN minus the small angle DMB equals to angle theta. Again, the big angle DMN minus the small angle DMB equals to angle theta. repeat again, the big angle DMN that is equal to 70 degrees in its size minus the small angle DMB that is equal to 40 degrees in its size equals to the missing angle again theta that is actually angle NMB that is the angle that we are looking for. And finally we found out that DMN that is 70 degrees minus DMB that is 40 degrees equals to 30 degrees. Okay, so actually we found out that the angle that we are looking for, angle theta that is actually angle NMB equals to 30 degrees in its size. Okay, thank you very much.